Hi there, and welcome to our video on data distributions. When we do statistics, we frequently have to think about how our data is distributed. This is simply necessary because there are statistical methods or tests which are based on assumptions regarding data distribution. A large part of statistics is based on the normal distribution because it's so easy to work with it. But how often do we find normal data in reality? Or which distributions are the most common ones in nature? And how can we determine if our data follows a given distribution? These are the questions we'll answer in this video. In this paper, the author Aidan Lyon states, "Strictly speaking, there are no quantities in nature that are distributed normally, or at least there are very few. However, there are many quantities in nature with frequency distributions that are very well approximated by normal distributions. The normal distribution occurs when many small influences, which are not related to each other, affect the outcome of an experiment. A typical example is the so-called Galton board. In this experiment, the path of the balls depends on the pegs inserted here on the top of the board. If enough balls and pegs are used, we will obtain a bell-shaped distribution, similar to a normal distribution. But of course, a normal distribution is continuous and there are no vertical separations, as in this board. Typical real-world examples of normal distributions are body weight or height, which are in fact influenced by many different factors or genes. Hence, weight and height are approximately normally distributed. But now let's look at some other distributions. How about the number of children per household? Let's have a look at this publication from UNICEF. In this histogram, we see that 2 children was the most frequent number per household, followed by 1 child and no child. Households with 3, 4 or more children were much rarer. This data is clearly not normally distributed. If you look further down in the study, the researchers have also measured how much money people spend per day for a household with or without children. Here we see another example of non-normally distributed data. Let's see other examples. How about age? This is the age distribution of the world in 2022. Red bars represent women, blue bars represent men. Here we see that also these data are not normally distributed, since younger people are much more frequent than older people. If these data were normally distributed, then we would expect such a curve. Another example, lifetime reproductive success of a seabird species. That is the number of offspring produced in the entire life of a bird. In this graph we see that most birds had no offspring. This happens because many birds die because being able to reproduce. The more we move up the x-axis, the rarer the reproductive success occurs. While having 1 or 2 offspring is still relatively frequent, having 10 or more is really rare. In this paper, the authors measured how much of a video is actually viewed by participants of the study. This is a relevant question for video sharing platforms. People could stop viewing at any time, hence the minimum they could see of a video was 0%, here 0 in the graph. And the maximum was 100%, the entire video, or 1 here in the graph. We can see that this is a skewed distribution. On average, people viewed about 60% of the video. So you can see that in reality, there are many cases when data is not normally distributed. But how can you decide if your data is or is not normally distributed? Well, here are some ways to do it. The first is think about your data. And the second is statistical testing. If you think about your data, you can already get an idea of how your data is distributed. For example, are there any limits? A family can only have no child, 1 child, or more children. There can never be a negative number of children. Hence, this data is probably not normally distributed, because a normal distribution extends from -infinite to +infinite. Another example of limits are percentages. A percentage can only extend from 0% to 100%, or if you use frequencies, from 0 to 1. Such data can only be described by a beta distribution. Here you see some examples of beta distributions. The second criterion is skewness. If you know that your data is not symmetric, but skewed to one side, then you already know that your data is not normally distributed. Such data is usually best described using a skewed distribution, such as a gamma distribution, Weibull, or Lognormal distribution. Finally, you can consider your data type. Sometimes the type of data may already indicate how your data will be distributed. Counts usually follow a Poisson distribution, which may look similar to a normal distribution only when you have many counts. The second option is to do a statistical test. If you want to test if your data follows a normal distribution, the best choice is Shapiro-Wilk's test. This test has been developed specifically for normal distributions, and it is very sensitive. However, make sure you have a large enough sample, for example at least about 30 values or more. If you want to test if your data follows a different distribution than the normal distribution, use Kolmogorov-Smirnov test. This test is only slightly less sensitive than Shapiro-Wilk's test, but it can be used for any kind of distribution. So that was a short wrap-up about data distributions. If you liked this video, please like, share and subscribe. And if you would like to see how to conduct distribution tests in practice, have a look at our next video.